elimination. Line them up and solve it that way. You can solve for one variable, set them y equals, solve that way. There's a number of ways you can do this. So, any suggestions for this one? What would you like to use to solve this?
Let's do substitution.
Okay, so what would you like to start with?
X.
And you want to solve for x in this equation?
Yeah, sure.
Okay, so if we solve for x in this equation,
Oh, well,
then we're going to have to substitute it into this one and this one, right? And we're going to have to square it.
I thought you were pointing to the top one.
Well, you want to solve for x in that one? You can't,
Okay.
right? Because it's an x squared and an x.
Yeah, you're right.
So, like, think this out a minute. If you solve for x in the second one, and then you substitute it in here, and it's absolutely doable. You just have to square it, and you have to worry about the subtract sign. So what would be an easier one to solve for?
Solve for y.
Solve for y. So if I add x minus 1, right? And now I can substitute that into this. Just be careful because you got a parentheses. You're going to keep that in parentheses because you got to subtract. So this is where your y was from substitution. We'll do your substitution method. So don't forget to distribute your negative sign. Collect your like terms. And you have descending variables. Get everything to one side. Subtract the 1. And then what?
Take out an x.
Take out an x. Let's factor out an x. And now you can set them both equal to 0. Are we done?
Yeah.
Sarah says no. Because why? We have to find y. We've got another one to find. Y. Now, the y should be nice because we already have it set up. Y equals. So we set our equation on both sides of these. Substitute in the 0. So we've got an x and a y. Substitute in. I'm taking a shortcut just showing you where it goes. And you get an x and a y. Okay. Now, you can go back and check them if you like. We manipulated your first equation, so maybe, well, we have it set up for your second, but throw it back in, either one, and check them. You can even, if you want, set them both equal to y, and put it in your y1. See if they, or where they intersect.
What does that first line say? Y equals x minus 1?
Yeah, I took it from here.
Oh, okay.
Wait.
You have two variables to solve for. We only solved for x. So Ashley, sorry.
You use it just like points on the graph.
Well, this one could be a point on a graph, but whenever we make our solution set, we're going to make it like that. If we have 3, we're going to hook all 3 together. And what you want to do is put it in alphabetical order so that it matches your variable. You don't have to come back and say x equals 0 and y equals -1, x equals 2 and y equals 1. Instead of doing that, we just do it as the x and the y right now, because this is kind of like a coordinate system.
Okay.
We're going to do something a little bit different, and we're going to put 3 of them in there. Not all the time do they have two solutions. When we use 3 variables, we'll usually have one variable for each. Now, what's another method I could use for this? Elimination. So what would you do when you eliminate? You add it. You first have to make sure that when you add them, you will be able to eliminate one variable. So if I add this together, don't I eliminate the y's?
Yeah.
Right? Or I have to manipulate them a little bit. So I have x squared minus 2x, the y comes out, and I'm equal to 0. And then I'm at the same step that I was right here. And then we would do the same exact thing. Right? So elimination is nice. If things line up and you see that you can eliminate, by all means eliminate. some kids like to automatically solve for y and then set the y's equal to each other. That's a substitution method, and that's perfectly fine. Excuse me. I think they like to solve for y equals so they can also put it in the y equals and see where they cross. This is a parabola. So a parabola can cross a line. This is a line. It can go twice. It can be once, tangent, or it could be none. So it's nice to kind of look at your graph if possible. If it's too much manipulation, then don't do it. But if you can look at it in y's equals, that's a nice way to do your graph. Okay? So we're looking at just solving systems of equations. Now, we get to this guy. How can we solve this? What's one way to solve? And which equation? Second one? If I solve for the y in the second one, I'm going to get a fraction, right?
Yeah, I'll solve for x in the second one.
Could we solve for x in the second one? Excuse me, thank you. In fact, before I even do this, can I eliminate one of those? Can I divide everybody by 2? Could absolutely do that first also. Or, like Rohan said, if you want to, you can solve for x in this one. I wouldn't solve for the y, only because you're going to end up with a fraction, and I mean, that's doable, but when you go put it back into here, I know a lot of you panic over the fractions. So if you want to solve for this guy, divide by 2. You can divide by 2 later, divide by 2 here. Take this, and then substitute it in where you see your x. So this is your substitution method. Okay, that's one method. And from there we can solve it. Do you want to continue to solve everything? All right, so this will give you 10y. There's a couple that I do want to solve because some have little weird things happening. Subtract 35. Okay, are we done?
Nope.
Nope. We got another variable. We want to take this and we want to solve for this. Plug this in, so negative 4 plus 7 is 3. So we've got now, be careful because even though you solve the y first, the x has to come first. The x is always going to come before the y. Whatever your variables are, just keep them in alphabetical order and you can always hook them up. What's another way to solve for this guy?
Elimination.
Elimination. You got your x's and your y's already lined up. Now the problem with elimination is these coefficients have to be the same and they have to be the opposite signs. So what would you want to do to eliminate one?
I was going to say, you just
Okay, what do you want me to do?
so you can make it from 5 and 2 into 10.
So if I make,
So 2x minus 4 with 5.
so multiply this guy by 5 and multiply the top by what?
2.
So if I multiply the top by 2 and the bottom by 5, they're each 10. So I want to make one the opposite side.
So the negative.
Which one? Okay. Now I just keep asking because does it matter?
No.
Does it matter? What's another way you could, what's another way? Anybody have another way to do it?
You do 4 and 3.
You can do 4 and 3 because they're already opposite signs. What it is you want to find the common multiple between both of these. You want to find the first common multiple. And then you want to make sure you multiply them both to match that. So we'll go with this. This is absolutely fine. We multiply it all the way across. We multiply the bottom across. And when you add down, you should eliminate a variable. and you're going to divide by a negative 26. Excuse me, I keep losing my voice. And then you can find your x from there. Okay? So to find x, what do you have to do to find x in this one? There's no x equals. What do you do to find x? Plug it into one of the others. So say you plug it into this one, then this one's a good one for you to check. If you find x with one of them, then plug it into the other one to check. It's a good way to do it. So you still can use either way that you want to do. We're only two variables, two equations right now. All right. Let's take a look at this guy. How would you like to solve it? Any suggestions? Ryan?
Did you multiply the top one by 2?
Okay, so Ryan would like to do elimination. He'd like to multiply the top one by 2, so I'm just going to bring it down here if that's okay. Oh, okay. So when we do this, they both eliminate, and we're left with 0 equal to 7. Is that a true statement? No. So as a result, there is no solution. That's it. If this statement comes down here, that's not true. But could you solve for x in this case? Could we do substitution and solve for x? Well, let's see what happens if we solve for x. Maybe we did something wrong. So now I'm going to substitute it into this x. So this gives us negative 4y minus 6 plus 4y equals 1. And again, they eliminated. Is this a true statement?
Nope.
Nope. So again, we proved no solution. Okay. If these are both lines, and there's no solution, what kind of lines are they? Parallel lines. They will never intersect. So if you wanted to, you could solve this one for y and this one for y, and you would see that they have the same what? Slope. And they'll never intersect. Always take a look at your equations. We did the first one, had a parabola. These guys are lines. They can intersect once or not. Okay, and that's it. All right. And last one. I think this is your last one.
Yeah,
Okay, any suggestions?
Multiply by -2.
Multiply by -2, the top one?
Yeah.
Okay, I'm just going to bring it right down here. So what happens here? Everything cancels out, right? So what am I left with? 0 equals 0. Is this a true statement?
yeah.
That is true.
Then this is all solutions. So these are both lines. What kind of lines are these if they're all solutions?
And the same
Same line. Good. They're the same line. Good? Okay. So I gave you the homework. You can probably get started on that. You could do substitution if you want to. Prove it the same way. It's going to come out the same thing.